Alright, 9.3, we're going to go over trig functions of any angle. So again, our trig functions we did in 9.1 and 9.2, I think. And that is our sine, cosine, tangent, cotangent, cosecant, and secant. So we're just doing more of our trig function stuff now. So we can find our trig function of any angle using this little circle we have in our coordinate plane. So it's going to give us a point. The first number in that point is our x. The second number is our y. And then we need to do Pythagorean theorem to find our r. So technically this is going to be a little right triangle here. We have our x and our y, and then our r is our radius of the circle. We do Pythagorean theorem to find that length. So always Pythagorean theorem is x squared plus y squared is equal to r squared. And then we have 6 little formulas down here for our 6 trig functions. We have the sine of theta is equal to y over r. Cosine theta is x over r. Tangent theta is y over x. And it makes a little note here that x cannot be 0. We'll have some examples where x is 0, so we'll get 0 in the denominator. Whenever 0 is in the So let's say we had 0 in the denominator. This would be undefined. So if we ever have 0 in the denominator, our answer is undefined. And then we have our reciprocals of our trig functions here. So sine goes with cosecant, cosine goes with secant, and cotangent goes with tangent. And they're just the flip. So since sine is y over r, cosecant would be r over y. So the reciprocals of each, you just flip them. So technically you only have to know your 3 formulas and then just know which reciprocals go with which, and you just flip them. But also on your test you can use your notes, so I would strongly encourage this to be on your notes. So this is super helpful. You want to make sure that you have this with your notes. Looking at this, we have a little right triangle here. X is our horizontal axis there, so this is our x. We're going to the left, whatever value our x is. Y is how much we go up or down, so this is our y. And r is our hypotenuse here of this triangle. So that's how we can do Pythagorean theorem to find r, because we have a little right triangle. If we were taking sine of this angle here, theta, we'll call the inside part theta, sine is opposite over hypotenuse, so that would be y over r. So yes, technically you're using SOHCAHTOA. If we were doing cosine, that would be the adjacent. Adjacent would be x over r. But instead of thinking about SOHCAHTOA every time, you can just use these little formulas here. But that's how they get all of these, is from SOHCAHTOA, because we have a little right triangle. So that was a great point. All right, so example 1. It gives us the point -4, 3 as on our terminal side of an angle theta in standard position, and we have to evaluate each of the 6 trig functions of theta. So we have our 6 trig functions are sine of theta, cosine theta, tangent theta, cosecant theta, secant theta, and cotangent theta. Now for each of our 6 trig functions, to evaluate these, we need to know what our x is, what our x is equal to, our y is equal to, and our r is equal to. So using this point, what's our x? -4. What's our y? 3. And then how can we find our r? Awesome. Pythagorean theorem. So -4 squared plus 3 squared is equal to r squared. What's negative 4 squared? 16. What's 3 squared? So 16 plus 9 is equal to r squared. 25 is equal to r squared. So what do we find what just r is? Take the square root, so we get r is equal to 5. So our r is 5. So once we have these three values, all we're doing is just plugging in. You'll have the formulas in front of you. So we need to know that sine is what over what? Sine is y over r. What's our y? What's our y? Y is 3, r is 5, so sine of theta is 3 over 5. Cosine is what over what? X over r. What's our x? Negative 4. Negative 4 over 5. So that is our cosine of theta. Next we have tangent. Tangent's what over what? Y over x. What's our y? 3. And what's our x? So 3 over negative 4. So those are our three trig functions, and we need to find the next three. So each one of these is the reciprocal. So all we need to do is flip it. Since sine is y over r, cosecant is r over y. So this would be 5 over 3. What would our secant be? Five over negative 4. And what's our cotangent? Negative 4 over 3. Perfect. So next we have the unit circle. So our unit circle is when r is equal to 1. So questions about the unit circle are always going to say, use the unit circle. And that means r is equal to 1. Whenever the question says unit circle, you know r is going to be equal to 1. The unit circle is just when our radius is 1. So it's like we go 1 unit this way, 1 unit this way, this way, this way. So that's why r is always 1. And that's what r stands for, is our radius of the circle. So we're just going 1 unit in each direction, which is why it's called the unit circle. So just like our formulas on the second side that we did, sine we know is y over r, but since r is 1, sine of theta is technically just y when dealing with the unit circle. Similarly, cosine of theta is just x when dealing with the unit circle, because r is 1, so x over 1 would just be x. So let's look at example 2. Use the unit circle, so it tells us to use the unit circle, to evaluate the 6 trig functions of theta is equal to 270. So our 6 trig functions, we have sine, cosine, tangent, cosecant, secant, and cotangent. All right. So let's draw our unit circle. We have our coordinate plane and our unit circle. And now we need to draw theta at 270 degrees. So just a reminder, our circle is 360 degrees, so each quadrant that we're in is 90 degrees. So we have 90 degrees, 180, 270, 360. So our theta goes from our initial side to our terminal side, which is at 270 degrees here. So this is our theta. We're looking at this 270 degree angle here. Now we need to figure out what our x and y are. So we want to see what this point is. What is our x and y coordinate at this point? What's our r here if we have the unit circle? What's r equal to?
1.
R is 1. So our radius of this red circle here is 1. So we're going down 1 unit. So what would be our coordinate point here at 270 degrees? Perfect. 0. Is it positive 1 or negative 1? Negative 1, because we're going down 1. So 0, because we're not going left or right anywhere. And negative 1, because we're going down 1. So it's just like a coordinate plane. All we're doing is moving down 1. So our coordinate point is 0, negative 1. So what's our x? 0. And what's our y? Negative 1. So once we find our x, y, and r, we just plug it into our 6 trig functions. So sine is what over what? Y over r. So our y is negative 1 over 1, which is what? Negative 1. Cosine is what over what? X over r. So we have 0 over 1. What's 0 over 1? 0. Tangent is what over what? Y over x. What's our y? Negative 1. What's our x? 0. What happens when we get 0 in the denominator? Undefined. So tangent of theta is undefined. Whenever we have 0 in the denominator, our answer is undefined. Now let's find our reciprocals. So if sine was negative 1 over 1, cosecant would just be 1 over negative 1. And what does 1 over negative 1 simplify to? Negative 1. If cosine was 0 over 1, secant is the flip, so 1 over 0. What does 1 over 0 simplify to? Undefined. And then cotangent is the reciprocal of tangent. So since we had negative 1 over 0, now we have 0 over negative 1. And what does 0 over negative 1 simplify to? 0. Whenever you have 0 in the numerator, your answer is 0. If you have 0 in the denominator, your answer is undefined. Let's do number 4 first. Since we just did the unit circle one, we'll do it again here. We'll come back to 1, 2, and 3. So number 4. Use the unit circle to evaluate 6 trig functions of theta is equal to 180 degrees. So here it says our unit circle. What does that mean r is equal to? R is equal to 1. Now we need to find what x and y are. So we're going to draw our unit circle here. 180 degrees. If this is 90, this one's 180. So 180 degrees, we go from here to here. So we're looking at this point here. What would be our coordinate point here? Perfect. Negative 1, 0. We're going to the left, negative 1, and we're not going up or down, so y is 0. So we have r is equal to 1. What's x equal to? Negative 1. And what's y equal to? 0. Now let's find our 6 trig functions. So sine of theta is what over what? Y over r. What's our y? 0. So 0 over 1, which is just 0. Next, we have cosine theta. Cosine is what over what? X over r. X is negative 1 over 1. What does negative 1 over 1 simplify to? Negative 1. Next, we have tangent. Tangent is what over what? Y over x. So y is 0 over x, which is negative 1. What does 0 over negative 1 simplify to? 0. Now we have our reciprocals, so next is cosecant. So cosecant theta is the flip of sine. So instead of 0 over 1, we have 1 over 0. What does 1 over 0 simplify to? Undefined. We have 0 in our denominator, so this is undefined. Next, we have secant. What would our secant theta be? Awesome. 1 over negative 1, which is just negative 1. And then lastly, we have cotangent. Tangent was 0 over negative 1. So negative 1 over 0, which is undefined. Next, let's look at number 1. So here we have to figure out what our x, y, and r are going to be given the given the 1 point that it gives us, 2 values. So what's our x? 3. What's our y? Negative 3. How do we find r? Pythagorean theorem. So 3 squared plus negative 3 squared is equal to r squared. What's 3 squared? 9. So 9 plus 9 is equal to r squared. What's 9 plus 9? 18. So 18 is equal to r squared. How do we solve for r? Square root it. How can we simplify the square root of 18? What are 2 factors of 18? Casey, you're right. You're just too quick. What are 2 factors of 9? 3 and 3. So our factors are 3, 3, and 2. Remember, we circle groups of 2. So we would circle our 3's. Whatever we circle comes outside, and whatever we don't circle stays inside. So 3 square root 2. So you always need to simplify. Once we find our x, y, and r, we can find our 6 trig functions. So we have sine theta, cosine theta, tangent theta. I'm going to do it down here so I have more room. So cosecant theta, secant theta, and cotangent theta. So sine is what over what? Y over r. What's our y? Negative 3. And what's our r? 3 square root 2. How can we simplify this? Can we simplify it any other way first? The 3's cancel out, so we have negative 1 over square root 2. We can never have a square root in our denominator, so we have to rationalize it. So how do we get rid of that square root? What should we do? Awesome. Multiply the top and the bottom by square root 2. Square root 2, square root 2. So we get negative square root 2 on the top, and what's on the bottom? 2. So that's our answer. So sometimes when working with square roots, it's a little bit more work, but definitely doable, not impossible. Any questions on that one? All right, let's do cosine. Cosine is what over what? X over R. What's our x? 3. So 3 over 3 square root 2. So we get 1 over square root 2. You got to do the same thing, or you could just look at the work you did above and know that it's going to be the same thing, just positive now. So we have square root 2 over 2. Let's do tangent. Tangent is what over what? Y over x. What's our y? Negative 3, and our x is 3. What does negative 3 over 3 simplify to? Negative 1. Now with our trig functions, cosecant, secant, and cotangent, all we have to do is flip the ones above. So cosecant goes with sine. Since sine was negative 3 over 3 square root 2, this is going to be 3 square root 2 over negative 3. What does this simplify to? Square root 2 over negative 1, which is negative square root 2. Remember, that negative could go on the top or the bottom or out front. Doesn't matter. So the 3's cancel. We just have negative square root 2. Cosecant goes with, or secant goes with cosine. So since cosine was 3 over 3 square root 2, this is 3 square root 2 over 3. What does this simplify to? Square root 2. The 3's cancel, so we're just left with square root 2. And then lastly, we have cotangent, which is the reciprocal of tangent. So this would be 3 over negative 3, which simplifies to what? Negative 1.